Hello everyone. Hope you are all doing well. Today we will move to the chapter Gravitation. So you know what is gravitation, children? You know the story of Sir Isaac Newton sitting under an apple tree and an apple fell on his head. So he started thinking why it happened. Later he found out that every body in the universe attracts every other body with a force called gravitational force. So before moving to the details of Newton's laws and the other things, we need to study something regarding centripetal force. So the first concept in this chapter is centripetal force. So what do you mean by centripetal force? Children, in your textbook you have an activity where we can take a string and tie it on a stone and we will whirl around so that we can see that the stone will execute in a circular path. So why is the stone remaining in that circular path? We have to think about it. So consider the example of a stone being whirled in a circular path by our hand holding it. So children, what keeps the stone whirling around a circle? So you have to think about it. The stone is attached to the string and our hand is directing the stone in its circular path by giving a force towards the center of the circle. So whenever body moves in a circular path and it continues to move in a circular path, there is a force which directs the body to move in the circular path, and that force which is acting towards the center of the circle along the radius of the circle is called a centripetal force. So actually this centripetal force, the word meaning is center seeking. So somebody asks you, what is a centripetal force? So what will you answer? The force acting on a body which is moving in a circle, and the force is acting towards the center of the circle along the radius. So the 2 points that you have to write while you write centripetal force is, what are the 2 points? Towards the center of the circle, towards the center of the circle in which the body is moving, and the second is along the radius of the circle, along the radius of the circle. And we know that a circular body moving in circular motion is always getting accelerated, right? And the acceleration of a body moving along a circle towards the center is termed by another term of acceleration called centripetal acceleration. So we know that usually bodies get accelerated, right? So centripetal acceleration is the acceleration on a body which is moving in a circle, and this acceleration is also directed towards the center as the force is directed towards the center. So what all we have studied, children? Centripetal force, the force which is acting on a body continuing in a circle towards the center along the radius is what is meant by a centripetal force, and the acceleration associated with that body is called centripetal acceleration. Now we'll discuss some of the examples in the case where so many bodies are moving in a circle. Okay, and we can get the example of sun, and earth is moving almost in an elliptical orbit around the sun. So which is the force which provides the necessary centripetal force for this motion? Actually, the gravitational force between the sun and the earth. The sun is attracting the earth, and this force, the gravitational force, is the agent which provides the necessary centripetal force for this motion. And also we can consider in the Bohr model of atom, there is a nucleus and the electrons are always revolving around. So what keeps the electron moving around a circle? The attraction of the nucleus by attraction of the nucleus to the electron is responsible for keeping the electron around the circle. And another extreme example where we know that there is a curve along the road and a car or a biker is moving along a curve of the road, and there is a chance that he can be thrown along the tangent, right? So what keeps the biker or the car along this curve is the friction between the tire and the road. So there are so many agents that we have studied. If there is no friction between the tire and the road, what will happen? The friction between the tire and the road is less. They may not be able to provide the necessary centripetal force to revolve the circle, and he may be flying along the tangent. So one question also will be attached to this part. If a body whirling in a circle is not provided with the necessary centripetal force, so what will the body do? The body will be thrown along the tangent of the circle. This straight line drawn along the circle is what is meant by the tangent of the circle. There is a chance of the body moving along the tangent of the circular path. So we have discussed what is centripetal force, what is centripetal acceleration. These are the examples where who is providing the centripetal force in the case of a stone? The hand is providing the net centripetal force along the string. And who is providing the centripetal force? The solar attraction towards the earth is providing the necessary centripetal force for the earth to move around the circle. And in the case of an electron, the nuclear attraction on the electron is responsible for keeping it. And for a biker or a car moving around a curve, what is responsible? The friction between the tire and the rod is responsible for providing the necessary centripetal force. And what happens when there is no centripetal force or an agent is failing to provide the necessary centripetal force? The body will be thrown along the tangent of the circular path. Hope you have got it well. Thank you.